Assalamu alaikum. My name is HarisAnjum and this is my project Facial Liveness Detection. Facial recognition is one of the most widely used biometrics in today's world. This technology is becoming prevalent in various fields including security, law enforcement, banking, etc. However, these systems are vulnerable to spoofing attacks, that is, the use of printed images and 3D models to bypass such systems. This is where facial liveness detection plays a vital role. It helps distinguish between real and fake faces by using multiple techniques. Facial liveness detection has grabbed the attention of many developers, and a great amount of work has been done on this field, by making use of methods like texture analysis and motion detection. This table here shows some examples, and it can be seen that multiple models like the linear binary pattern and deep CNNs have been used by various researchers. Overall, this is a field that is continuously developing and expanding, but there are still some challenges that need addressing. With the increasing use of deepfake technology that develops highly realistic models of any individual, facial recognition systems are at a high risk of being fooled. In this project, the approach that has been used is binary classification. The model is made using a neural network with multiple layers that is able to classify real and fake images. So this is the basic structure of my project. The app file here is the main file that uses the Flask library to create a user interface. We will be coming back to this file. The templates folder here contains the HTML files for the front end. The static folder contains the CSS files. This is our main folder, face recognition and liveness. Inside this folder, we have two subfolders, one for face liveness and one for face recognition. The face recognition contains two files, encode faces and the recognize faces. The dataset I provided were some images of myself. These are the images I provided to as the dataset. The encode faces file here uses the face recognition library of Python to create encodings on the images, and then it saves these encodings on in the pickle file here. The recognize faces file makes use of the same library face recognition on runtime, and it creates the encodings on the face and then matches the encodings with the pickle file. And if they match, then the name of the person is displayed on the webcam. So the face liveness detection, I provided two kinds of dataset. One was the video. The real video I provided was a video of myself while I moved around in my room. This is the video. And the fake video was the same video I played in front of my webcam. Now, the collect dataset file here uses the deploy proto.txt file. This is the detector and the CAF model. It detects the face from the videos and then saves the region of interest in this dataset folder in separate fake and real folders. The same thing has been done in the images. The images I provided were some real images of myself. These selfies I took of myself. These are the real images, and the fakes were the ones I captured from my student identity cards. These are the fake images. The same thing was done on these images in the face from image file. The same detector was used and it detected the faces and created the face ROIs and then saved them in the dataset folder in separate fake and real folders. This is our main dataset for the face liveness detection. Now our model is created in this file here, livenessnet. As we can see, our model is created using the TensorFlow library of Python. Two convolutional layers have been used, both with the rectified linear unit activation function, followed by batch normalization and max pooling. Then finally we connect the layers and use the output layer. The function that is been used is the softmax function. Then the training of this model is in this file, train model. First off, we split the dataset 80-20. 80% data is used for training and 20% data is used for testing. This is the split here. The initial learning rate is 1 into 10 raised to power minus 4. The batch size is 4 and the epochs are 50. We use the atom optimizer for this model. and then the model is trained. The predictions are made on the test data, and then the accuracy is plotted. This is our plot here. We can see that we have achieved almost a 90% validation accuracy. Our liveness model has already been trained. This is the liveness model, liveness.model. Now, let us run our code from this main file. So, the user here I have created as myself. Now, as I sign in, the webcam will open and then it will recognize if it is really me or is another person trying to log in as me by using a printed image of myself. So, as we can see here, uh, it correctly identifies between the image and the real person, that is myself. So now it will wait to capture 15 frames of my face, and then it will further move on to our main page. And this is our main page. So the dataset has been described. These are the face ROIs that are collected from the real and the fake videos that we used. The methodology has been defined. This is the basic workflow model. The input video is fed into the face detector that crops the face and saves the face ROIs. The real and the fake faces are fed into the training script that uses the liveness model that we created and then trains our model. The results have been shared. This is the accuracy plot that I have already shown. These are the results in real time. So this project overall highlights the importance of liveness detection systems, the growing need for such systems, and that is what our model provides. So in conclusion, I would say that our model was successful, and by making minor improvements such as increasing our dataset, it can be implemented in a real world scenario. Thank you.